We already have processes, so why do we need threads? Recall from our discussion in the previous unit that a process includes many things. When we create a process, among other things, we need to space some allocate for this process in the main memory. This is where we'll bring in all the code and the data for the process. So this data would be the global variables and the other constants that the process might be using. The process has all of this in its address space. Besides this, during execution, the process would be using several operating system resources. So for example, the process could be accessing various IO devices. It may have several files open in the hard disk. The operating system needs to keep track of all of these open resources and files. Plus, there needs to be other accounting information. For example, maybe the runtime of the process, how long the process has executed on the CPU so far. This information may be needed by some scheduling algorithms, and if it's a paid server, it may also be needed for billing purposes. Further, the operating system needs to maintain the execution state of the process. So for example, what is the value of the program counter? This will tell us where in the program which instruction the process is executing right now. The operating system needs to keep track of the stack pointer. So this will be used for managing the program call stack, for calling and returning of functions in the program or the process. We also need to keep track of the state of the register file for this process. And if there is any other system state associated, maybe for example the program status word for the process and so forth. So there is a lot of accounting information that is associated with each process, and because of this, processes are expensive. Anytime we are creating a new process, it's a costly affair for the operating system, because so many operating system resources and system resources need to be allocated for the process. So many different data structures need to be initialized to represent the process in the operating system's memory. For example, the program PCB, the process control block. Essentially, there is a lot of additional overhead and work that the operating system needs to do in order to facilitate the execution of a process. Besides this, if you have multiple cooperating processes, let's say you have multiple processes that are working on solving a large problem in parallel. Now these processes would need to communicate so that they can correctly solve the problem in parallel and save time. However, communication between processes is also costly, because anytime you want to communicate between processes, you have to use the operating system calls somehow. In some form, the communication goes through the operating system. So because of all of these reasons, the processes are expensive.